Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about some basic concepts in probability. So in this lesson, I'm going to first introduce the probability experiments, then the law of large numbers, another way to state the definition of probability. Next, I'm going to show you how to compute the probabilities for equally likely events and how to approximate probabilities for not equally likely events using empirical rule. So now let's get started off with probability experiments. To understand what a probability experiment is, let's consider this example of tossing a coin once. So when you toss a coin once, you really cannot tell ahead of time whether the coin lands head or tails. However, if you repeat tossing the coins a large number of times, say 10,000 times, we can observe that the coin will land head approximately 5,000 times. Here, tossing a coin is an example of probability experiment. So, a probability experiment is one in which we do not know what any individual outcome will be, but we do know how a long series of repetitions will come out. And the probability of an event is the proportion of times the event occurs in the long run, as the probability experiment is repeated over and over again. Another way to state the definition of probability is to use the law of large numbers. The law of large numbers say that as a probability experiment is repeated again and again, the proportion of times that a given event occurs will approach probability. Here is a graph showing how the probability of getting head changes when the number of tosses increases. So you see that at the first toss, right after the first toss, we got one head out one toss. So the probability of getting head is 1. After 5 tosses, the proportion of head was 0.6. That means we got 3 heads and 2 tails. And we repeat the experiment. After 100 tosses, the proportion of heads was 0.49. That means we have 49 heads and 51 tails. And after 10,000 tosses, the proportion of heads was 0.4994, which is approximately 0.50. So we see that when the number of tosses increases, the probability of getting head approaches 0.5. And 0.5 is the theoretical probability of getting head when we have only 2 possible outcomes, head and tail. It's just like winning and losing. Probability models and sample spaces. To study probability formally, we need some basic terminology. The collection of all the possible outcomes of a probability experiment is called a sample space. For example, when you toss a coin twice, there are only 4 possible outcomes: head, 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 tail, tail, head, and tail, tail. So here the sample space is notated as capital S, and S is a collection of 4 ordered pairs. The first one is head, head, then head, tail, tail, head, and the last one is tail, tail. If A is an event of getting head at the first time, A is basically a collection of 2 ordered pairs, head, head, and head, tail. So here's the definition of sample space and event. A sample space contains all the possible outcomes of a probability experiment, or a sample space is a collection of all possible outcomes from a probability experiment. and an event is just an outcome or a collection of outcomes from a sample space. Usually we use capital letter to denote an event. And the probability of an event A is denoted by P of A. Now I'm going to show you how to compute probabilities with equally likely outcomes. Let's consider when a fair die is rolled. Find the probability that an odd number comes up. Here the keyword is fair. A fair die means the probability of getting any number among 6 numbers 1, 2, 3, 4, 5, 6 should be the same. So 6 outcomes are equally likely. So here a sample space is a collection of 6 equally likely outcomes. 1, 2, 3, 4, 5, and 6. And the event of getting an odd numbers is a collection of 3 outcomes, 1, 3, and 5. So the probability of getting an odd number is 3 out of 6, signified to be 1/2. In general, if a sample space has n equally likely outcomes and an event A has k outcomes, then the probability of event A is k over n. And the probability of any event is always between 0 and 1. In this course, we have 3 important types of events. Impossible event is an event whose probability is 0. That means it's impossible for this event to occur. A certain event is an event whose probability is 1. That means we're 100% sure that this event occurs. And an unusual event is an event whose probability is less than 0.05. The probability is sufficiently small. So that was how we compute the probabilities for equally likely events. Now we are going to apply the empirical rule to approximate probabilities when the number of experiments is sufficiently large. Let's consider an example. The Centers for Disease Control and Prevention reports that there were 2,046,935 boys and 1,952,451 girls born in the United States in a recent year. Approximate the probability that a newborn baby is a boy. So here first before we find probability that a newborn baby is a boy, we need to find the number of total births in that recent year. So basically we add up the 2 numbers and we realize there were 3,999,386 births. So the proportion of births that are boy is 2,046,935 divided by 3,999,386, and the proportion is about 0.5118. So the probability of boy is around 0.5118. So that's everything for today. Now we are going to do some practice. Problem number 1, fill in each blank with the appropriate word or phrase. If an event cannot occur, its probability is, so here if an event cannot occur is an impossible event. The probability should be 0. If an event is certain to occur, its probability is 1 because we're 100% sure this event to occur. The collection of all possible outcomes of a probability experiment is called a sample space. An outcome or collection of outcomes from a sample space is called an event. Problem number 2, determine whether a statement is true or false. First, the law of large numbers states that as a probability experiment is repeated, the proportion of times that a given outcome occurs will approach its probability. This is true. This is right at the statements of the law of large numbers. Second, the empirical method can be used to calculate the exact probability of an event. This is wrong because we cannot calculate exact probability of an event using empirical method. This method is applied when we approximate probability of an event when the number of experiments is sufficiently large, so not exact. Now problem number 3. Roulette wheels in Nevada have 38 pockets. Their numbers 0, 00, and 1 through 36. On each spin of the wheel, a ball lands in a pocket, and its pocket is equally likely. First, if you spin a roulette wheel 38 times, is it certain that its number will come up once? Number 2, if you spin a roulette wheel 3800 times, is it certain that its number will come up 100 times? 3. As the wheel is spun more and more times, will the proportion of times that its number comes up approach 1 over 38? For the first question, when you spin a roulette wheel 38 times, you cannot guarantee that its number will come up once. So the answer is no. Even when you spin it 3800 times, you still cannot say for sure that its number will come up 100 times. You can say that its number might come up around 100 times, but you cannot say exactly 100 times. So the answer is still no. Number 3, as the wheel is spun more and more times, so that means the number of spinning is getting larger and larger. Will the proportion of times its number comes up approach 1 over 38? The answer is yes. This is just due to the law of large numbers. Problem number 4 is the following a probability model. Why or why not? Here's the first model. So in this model, we have 4 possible outcomes and their probabilities. To verify if this model is a probability model, we need to verify 2 things. The first thing is its probability should be between 0 and 1. And the second thing is they add up to be 1. So here we see the first property is sci-fi. All of these numbers are between 0 and 1. However, they add up to be 1.53. So this is not a probability model. The second model, we also have 4 possible outcomes and their probabilities. These 4 probabilities are between 0 and 1 and they add up to be 1. So this is a probability model. The third model, 4 possible outcomes. We have 4 probabilities. These probabilities are between 0 and 1. So the first property is sci-fi. And they add up to be 1. So this is a probability model. The last model, 4 possible outcomes and there's probabilities. However, you can see that the probability of tailhead is negative 0.18. So the first property is not sci-fi. So this is not a probability model. Problem number 5, pitching. During part of a recent season, pitcher Ubaldo Jimenez threw 2,825 pitches. Of these, 1912 fastballs, 228 curved balls, 457 sliders, and 228 changeups. First question, what is the probability that Ubaldo Jimenez throws a fastball? And what is the probability that he throws a breaking ball, either curve or slider? So for the first question, we noticed there were totally 2,825 pitches. And we have 1,912 fastballs. So the probability of fastball is 12 over 2825. And the probability that Ubaldo Jimenez throws a breaking ball either curve or sliders is 228 plus 457 over 2825. And the answer is 685 over 2825. So that's everything for today. Thank you so much for watching, and I hope you guys enjoyed my video. See you next time. Bye.